Thank you so much for the chance to speak about an issue that I think is incredibly important. I know we all do. I wanted to start with kind of an unusual perspective. I wanted to tell you a little bit about my scientific career because I think it helped to bring me around to participating in Astronomers for Planet Earth. So back in 1990, I was working at the Lick Observatory above San Jose, and exoplanets were just being discovered at the time. And I was on the other team working on exoplanets. And I feel that most of my career has really been focused on error budgets. So, thinking about whether we can find Earths with this radial velocity method and how we can reduce the error budget. So this is a sketch of the quadrature sum of all of the error terms. And so I then began really teaching myself a lot about engineering and optics, and built 3 spectrographs, was the PI for 3 spectrographs. So here you can see first light on Express, the extreme precision spectrograph, which we have now commissioned at the Lowell Observatory telescope. Here's the vacuum chamber being lowered into place in 2019. And here are the results. So from Vincent Boyer's paper in 2018, looking at the archival data for 55 Cancri, has 5 planets. Here's a comparison with the Express data. And so I think you can see that the error bars have really shrunk down. And in some sense, I think it's even better to look at this system. So here are some Keck high-res data before on the star, quiet star, and you could look at the data and wonder, is there a planet buried in that noise? And so the Express data really, pound down on the error bars and have, reduced the RMS scatter to below 0.5 meter per second in 2.5 years of data. And so this is just, again, all about getting to the, I don't know why I'm not advancing now. I guess my program wants you to just stare at this because I can't advance. I'm going to stop sharing and try again. Maybe I can play from here. Okay. So this is the point is that I spent 25, 30 years of my career really focused on searching for exoplanets. And as I was finally achieving all of the goals that I had set out for myself, I just became incredibly uncomfortable with this, growing issue of climate change. And the sense that, great that we're discovering amazing new things, but if we don't save our planet, if we don't retain a habitable world here, then what does it matter? And so, as Victoria said, in 2019, I co-founded Astronomers for Planet Earth with a group of colleagues. We very quickly merged with the Astronomers for Future. And we've been working together for now almost 2 years to address the climate crisis from an astronomical perspective. The point is, as we all know, climate change is real, it's bad, it's us. Everybody agrees, all scientists agree, but there's reason for hope if we take action. And the statistics that are impressive are that these come from the Yale Climate Connection statistics, that only 10% of the people in the US dismiss climate change. So 90% of the people are interested, but they don't fully understand it. 40% think climate change is natural, and only 26% of the people are very worried. So to me, the most serious threat is the roughly half of our population, or 3/4 of our population, who think that climate change exists, but maybe it's not that urgent. Maybe it's not something that requires action right now. And this is where we as astronomers, I think, can play an amazing role. So why astronomers? What can we do, right? There are climate scientists, but in fact, we're trusted scientists without a conflict of interest. We have an enormous network. We teach introductory astronomy classes at small colleges, large universities. We run planetarium shows. We give sidewalk astronomy presentations with small telescopes. We're connected with amateur astronomers, which make up also a huge number of the really interested lay public. many of us use, or we at least understand or could understand if we spent some time reading papers, the Earth global climate models, and we've used them and applied them in the case of exoplanets. And then finally, I think it's impressive that as astronomers and space scientists, as we go out and explore the universe, one of the common things that we always do is look back at the Earth. So we can share these incredible images of the Earth that started with, I think, Apollo 11 took the first images of the Earth that also had the moon in that frame, to the pale blue dot, the image taken by the Voyager 1 spacecraft, just as it was leaving the solar system. And these images, I think, really provide a special view of the Earth, inspire awe and wonder, and also a sense of fragility of our planet. Another reason why astronomers is that the climate change is really beginning to affect our ability to do research. So if we think of it purely from that very selfish standpoint, in 2018, here's a fire that threatened the Griffith Observatory near Los Angeles, also the Mount Wilson Observatory. These are every year, right? So 30 years ago, 40 years ago, there were 10,000 fires, wildfires a year in the United States. And in total, they burned about 1 million square acres. Now, for the last 5 years, there have been something like 50 to 80,000 wildfires per year, and they're burning 10 million square acres, and they're getting dangerously close to our observatories. Here's the Lick Observatory. I showed you the first picture of my early career sitting up here at Lick Observatory, and a fire last year threatened that observatory. It came very close. You can see it coming up the mountain with the observatories, with the telescopes in the foreground. And then finally, the Express spectrograph that I spent my whole career really sort of, training to do and then finally building, is at the Lowell Discovery Telescope in the Coconino National Forest near Flagstaff, Arizona. And let's see, a week and a half ago, the Coconino National Forest was shut down because of forest fires. So beginning June 23rd, the observatory was evacuated, and we have not been able to go back since. Even if the fires don't take the buildings, the smoke still causes the telescope domes to be closed and cause problems for the optics in our telescope. So why should you join? Well, first of all, climate change is everyone's concern, right? Every one of us at this point, it's gotten so bad, it's accelerating so quickly that it's really going to take an all hands on deck approach to turning things around. And I used to really believe in the political process and believe that for something as big as climate change, that the politicians would figure this out and put policies in place that would improve things. And at least what I'm seeing right now in the United States is that it seems to almost be going the other way, that there's this concerted effort to protect the fossil fuel industry. And so the answer is not going to come from the politicians. It has to come from the people. It has to come from activism. And so I think here we're stronger together as a community. And with Astronomers for Planet Earth, you will learn how to provide some thoughtful advocacy for institutional change, how to ask that your institution not invest in certain industries, fossil fuel industries, especially ones that are particularly dirty. So there's a lot that we can do. We have curated webinars that provide an astronomical perspective. So it doesn't take very much to bend this topic into so that it fits really nicely into introductory astronomy classes. In fact, I've been doing this my entire teaching career, even before I've become as concerned as I have been in the last 5 years. There are, if you're just beginning to think about teaching climate change in your classes, We provide some assignments and some project suggestions. For example, the En-ROADS Climate Simulator is a really wonderful tool for helping students to figure out what's going on with climate change and what the possible solutions might exist. We help you to measure your greenhouse gases in a new rollout of our webpage that's coming out soon. You'll measure your greenhouse gases. You'll be told what the Paris Accord thinks they should be. And then when you don't fit into that box, you'll be able to select from a menu some things that you think you can do, and you'll see the impact that those actions will have. We have slides for teaching that you can drop right into your classes. We're making some video productions, and we're collecting images that you can use when you give talks. And then finally, we have events. So like the EAS conference, the Astronomical Society of the Pacific, in fact, is going to devote the entire summer session on July 23rd to an A4E meeting. And in that, for example, I'll be giving a demonstration on using the En-ROADS Climate Simulator and talk to people about how that became such a high impact project for my freshman seminar class. So I recently heard a quote: the best time to start reducing greenhouse gases was 25 years ago, but the second best time is right now. So I hope that you'll join us. Here's our URL, astronomersforplanet.earth, and you can go there and join the now more than 1,000 astronomers who have joined this project and are having, I think, an impact. Finally, I want to end with this note. We have an open letter, which was organized by Astronomers for Planet Earth. We want to invite you to sign it. The letter is still open and available to sign. It was released or opened initially on Earth Day 2021. And in it, we're demanding climate action from our institutions. We have already signatures from 2,776 professional astronomers, students, and educators, including two of our favorite Nobel laureates, Michel Mayor and Didier Queloz, Sir Martin Rees, present and former presidents of astronomical societies, unions, and collaborations, and several departments and institute chairs. We represent 93 countries, and we have endorsements from astronomical institutes. So there will be a press release, a press event tonight at the meeting at 6:15 European time. And you can see the A4E website for the full letter and for a way to sign. So thank you.